Have you ever wanted to do a test drive of Cisco ACI but don't have a lab? If that's the case, stay tuned. In this video, we're going to build a virtual lab using the APIC simulator, and then I'm going to talk about the use cases for which I use the simulator. Let's dive right in. First things first, you're going to want to download the code for the Cisco ACI simulator from the Cisco software website. That's software.cisco.com. And then you're going to basically type in APIC for Application Policy Infrastructure Controller. And then out of the options, you're going to select APIC Software. If you were to look at the older options or the options related to the suggested software release, you will see that there are some OVA images that also specify simulator. Now, the problem with these older images is that they typically require you to download 6 or 7 very large 10 gigabyte files and then merge them together. It's a complicated process, so if you're just trying to get your feet wet for the first time, I would suggest you go into the 6.0 releases, at least the newer recent releases like, let's say, 6.04c, and you're going to go down to the simulator OVA image. You see that this one is about 11 gigabytes. You would just press this icon over here and download. Of course, you do need to have access to download code from the Cisco website to be able to download this. But once you have downloaded it, you're basically going to install it on an ESXi server. So let's go ahead and talk a little bit about how you would do that. In my case, the ESXi server that I have installed it using 2 virtual switches. If I were to go under vSwitch 0, you will see that I have 1 VMNIC, and this is basically my connectivity to a network switch. And then I have another virtual switch that is called vSwitch 1. We're going to install it on vSwitch 1. The only thing differentiating between these two is that one of these virtual switches within the ESXi server connects to one switch. The other virtual switch connects to a different switch. And I'm using this for management of the server itself, services like vMotion, etc. If this were part of a cluster, it's not. And then vSwitch 1, if again, for connectivity to certain virtual machines that have to land on a other switch. In your case, whatever vSwitch you're going to install it on, the vSwitch itself is not of significance. It's actually the port group that does have to have certain settings configured on it for this to work. So I'm going to go under networking, and I'm going to create a port group specific to the ACI simulator. Again, you don't have to. I'm just trying to separate this just to show you exactly the process. In my case, I'm going to select a VLAN ID of 0. That basically means that the northbound switch is going to be configuring the port as an access port. Whatever VLAN that port has been configured as will be the VLAN that will be used. So again, VLAN ID of 0 here just means it's an access port. The network side is assigning the VLAN. I'm going to assign it to vSwitch 1. The security does matter. We will talk about this at the end. Basically, if you want to know, the settings that have to be configured for this to work are going to be accept and accept. But I do want to show you kind of what happens if you don't select these two. And so I'm going to keep it at the default for now. I just created the port group. Now, if you look at the virtual switch, vSwitch 1, what you will see is that from the virtual switches view, it has one network adapter, one cable basically to the northbound switch. It then has a port group, basically a VLAN assignment that you can then attach a virtual machine to. And then we also have another port group in the same setup, basically a VLAN ID of 1. But again, I'm trying to keep this separate for the purpose of this demo. Next, you're going to actually deploy the virtual machine. I'm going to right-click here, create register VM, and I'm going to deploy a virtual machine from an OVF or OVA file. I'm going to hit next. I'm just going to call this ACI simulator, and then select ACI Sim 6.04c and select open. That is the file that I downloaded. Going down, you're going to hit next. Here you're going to select what storage on the ESXi server you're going to be using. You see that I have 5 terabytes of free space. I'm going to hit next. The network mapping, it automatically selected ACI simulator. In the case of the simulator, if you do have a DHCP server connected to that particular VLAN, the simulator will automatically get an IP address. It would be assigned to the out-of-band port on the simulator, basically. I'm not going to use that. I'm going to basically manually assign the IP addresses. The disk provisioning of thin is fine. It'll basically ensure that you're taking the least amount of disk space, and I'm going to hit next. And finish here to start the process. Now, if I were to go under recent tasks, you will see that this is going to take some time. So I am going to remove myself from the picture and let this video fast forward to the end. We're back. So if you're wondering, in my case, it took about 5 minutes for me to deploy the OVA. However, the OVA actually was on this server itself. So it was on a jump box. This jump box that I'm showing you is actually on the same ESXi server. It can take a long time because it is a large file. Once you download it, you're going to go under virtual machines, and if it allows me to, let me find the file. So that is going to be this ACI simulator file. It is still working on it, it seems. I'm going to right-click on it and go under Edit Settings. Now, you will see that it created it with 12 vCPUs, 32 gigs of memory, and 200 gigs of hard disk space. 32 gigs allows you to use a small topology. And what we mean by small topology is that it will create a virtual spine, 1 virtual APIC, and 2 virtual leafs. In a basic scenario, that should be sufficient. However, I want to show you the worst case scenario of what happens when you want to have 2 leaves, 2 spines, and 3 APICs. So I'm going to wait for this process to finish, and then I'm going to show you how to increase the CPU and memory to a point where you can actually deploy it in a large topology. Okay, so in my case, it did take a little bit longer for the process to finish, but basically it auto started the virtual machine and I shut it down. If you were to select the virtual machine and then go into Edit Settings, you'll be able to update the vCPU allocation as well as the memory allocation. For a large topology, you're going to want to have at least 16 vCPUs. And then for memory, it's going to be 64 gigs of memory. But in my case, I'm going to add 2 extra just so it's 66. For some reason, the system, when you log in, it'll be obvious. It kind of shows you 2 gigs less than whatever you actually allocated to it. So I'm just going to add 2 gigs so it recognizes that you have 64 gigs or more. Once you do that, you're going to power on the virtual machine, and I'm going to take you through the initialization process in case you are more familiar with the ACI GUI and don't know how to initialize a fabric. I'm going to go over not necessarily the exact details of how you would do it in production, but basically how you can make sure that you initialize this large topology. So as it's booting, I'm going to select the console and basically show you what is happening. I'll just remove myself from the picture and I'll be back whenever there's something to cover. Okay, so here it's explaining the requirements, and you see that it says that the default simulator, which is the small topology, is 1 APIC, 1 leaf, 1 spine, a difference from the early days, which was still 2 leaves. And then the large topology is 3 APICs, 2 leaves, and 2 spines. We actually selected 66 gigs of memory, but it's still showing us 64 gigs, so that's why I did the 66 gigs. And select large topology, I'm going to type in Y, so it continues with the large topology deployment. Now what's going to happen here is it's going to show you 3 options, an option for an Alt F1, which is basically going to put you on the console for APIC 1. You press Alt F2, it's going to put you on the console for APIC 2, and Alt F3 is going to put you on the console for APIC 3. So when you initialize a fabric, you're always going to want to go on the console of APIC 1. In the case of current code revisions, what you do is you bootstrap the first APIC, you enable certain parameters. It's only going to ask for the password from APIC 1, and then you basically log into the GUI, and in the latest codes, you're basically going to use that GUI to tell ACI the SIMC credentials for the other APICs. And this is, again, a production environment, and we're not talking about a simulator environment. So what I want to impress upon you is that there are some differences between the simulators and the actual APICs. So let me bring this not in a jump box, but instead I'm going to log directly into the ESXi server. And now I'm going to directly connect to the console of that system. See if I can full screen this. If we were to look at the various options, it's going to give us some defaults. I'm going to keep all of them at the defaults because the way that the simulators work is that if the TEP pool and certain parameters are changed in any way, shape, or form, you aren't going to be able to form a cluster amongst your APICs. So in this case, I'm going to enter fabric ID of 1. I do believe that the fabric name can be changed. The fabric ID, realistically, in a simulator, I don't know that there are any reasons why you would change the fabric ID. Okay, so I'm going to select the fabric ID of 1. Here it's asking how many active controllers do we have. Obviously, in a simulator environment, we cannot have more than 3 anyway. So I'm just going to select the default. Is this a standby controller? A standby controller is a controller that basically does nothing until there's an outage, and then it helps to reestablish a quorum. And this is not going to be an environment where we have a standby because you just don't, we don't have a reason to in a simulator. So the controller ID is going to be 1. Now, if I were to log into the second controller, it'll automatically show 2, whereas in the real world, if you are bringing up an APIC, it's not going to do that. It has no way to know. In the case of the virtual simulator, you're just going to hit enter and make sure that it just continues. Is this APIC connected to Fabric over layer 3 network? This is a new feature, and it allows you to basically have a complete virtual APIC cluster. And in that case, it's possible that you may not have the virtual APICs be directly L2 adjacent to the fabric. That's really what this question is asking. In the case of the simulator, it does not apply. Pod ID is going to be 1. APIC name, you can change this. Let's say I call this DC1 APIC 1. The TEP pool, do not change this in a simulator environment. And the VLAN ID, infra VLAN ID is going to be 4. If you change that, the discovery will not work. I'm going to keep the bridge domain multicast address as default. You can change the out-of-band management address. This is how we are going to log into the GUI. I'm not going to enable IPv6 though, so I'm going to select the default of no. And then I am going to change the IP address in my case to make it routable and so that I can access it. I'm going to give it an IP address of 192.168.5.155.25. And the default gateway is 192.168.5.129. And with that, you enter a password here. This is the password that you're going to use to log into the GUI. And do you want to edit the configuration? I don't want to change anything in the configuration. I didn't make any mistakes. So I'm just going to select the default of no. Once you do this, the APIC IP address that we just entered should eventually become accessible on the network. Now, what is going to happen is that if I were to wait until this is complete, I don't expect to be able to log into that address because the IP addresses that the port group settings that I implemented don't have forged transmit set to allow or accept. I also need promiscuous mode set to accept, and I just want to be able to remind you a few times. So I just hit Alt F2. It jumped onto the console of the second APIC. I'm going to enter the fabric name as default. I do believe that the fabric name can be changed for the simulator. Most of these, so you see the controller ID by default, it knows that this is controller ID of 2. I'm going to just hit enter. Most of these, you're just going to hit enter. DC1 APIC 2, you can change that. You don't want to change the TEP address pool. You do not want to change the VLAN. And in this case, I do want to select a different different IP address. So 156 is going to be the last octet, and then 192.168.5.129. Would you like to edit? No. I'm going to then jump onto the third. So you're going to want to bootstrap all 3 of them. The way that ACI works is that the cluster between the APICs needs to form through the fabric. So we're going to bootstrap the APICs, give them some very basic parameters. It uses those basic parameters in the fact that they are all set properly to the same exact values to know that they actually are supposed to cluster. And once they cluster within the fabric, that is when the APIC 2 and APIC 3 are going to synchronize their passwords with APIC 1. So again, just the defaults for the most part. So technically, I should be able to, at this point, ping the addresses if everything is fully functional. let's go ahead and try that. And what I would expect to happen is that this will be unpredictable. And if you do have this type of problem where, let's say, it works a little bit, then it doesn't, that's the case when you definitely want to go into the networking section and under the vSwitch 1, let me make sure that that is the case here. Okay, it looks like I can ping all of them. And let me see, edit settings, security. Okay, so promiscuous mode, MAC address changes, and for transmits were actually set to accept at the vSwitch level. So basically, even though I didn't set it at the port group level, the fact that these three were selected at accept is what is allowing me to actually learn all of those MAC addresses. Because the way that the system works is that each of these APICs is going to have a MAC address, and there are going to be a few other MAC addresses that it's going to show. And without the forged transmit and promiscuous mode, the communication will not be such that will allow you to connect properly to the simulator. So again, at the vSwitch level, you can enable that, or you can enable that at the port group level. I'm going to go to edit settings. Again, here is where you would select accept. Not really required for MAC address changes, but you do need to select accept for these two parameters, promiscuous mode and forged transmit. So once you have that in place, you can then go ahead and log into that address. I'm going to go and log into APIC 1 because that's the only one that should be should allow you to log in. That's going to be 192.168.5.155 in my case. I'm going to then enter my credentials. And again, the reason why you won't be able to log into anything other than APIC 1 is that the other APICs don't even have a password. So you see the version. I'm going to enter admin and my credentials, the one that I entered in the setup. I'm not going to use the wizard. I'm going to basically go under Fabric and under inventory and then Fabric membership. And what you want to do is you want to register the various nodes. Now you will see that the first node, you see the suffix of 101, that's basically the node ID that you most likely need to use for this to fully discover. I'm going to use in my case, I'm just going to use tep-1-101 as the node name. And the node ID that I'm going to use here is going to be 101 and register. And I'm also going to wait for this to go into registered nodes. So once a leaf gets discovered, and the discovery basically means that the APIC sees the leaf in its LLDP output and the leaf sees the APIC in the LLDP output, there is a DHCP discovery process that happens. And once the leaf says, hey, I do request a IP address, and I do want this IP address that you've given me out of the TEP pool, what happens is that the IFM process starts and they're able to establish secure connectivity. Before that is possible, before the full activation of a leaf is possible, the process requires that an administrator register the switch, and that's basically when the actual IP handoff takes place and the leaf joins the fabric. Now you will see here that this leaf, its status will eventually go into active which means it is able to forward traffic. And somewhere at that point, you'll see that a spine or both spines will pop up in the nodes pending registration section. Now, while we're waiting for this, I want to show you under the system menu. If you were to go under controllers, you will see that from the perspective of APIC 1, it's not going to have any idea that there is an APIC 2. Because again, as I said, the way that this works is that the APIC is going to use its in-band connectivity into the fabric to be able to communicate with the other APICs indirectly. So we have to basically discover one leaf. In some environments, one leaf is sufficient if all the other APICs are directly connected to that leaf for a cluster to form. However, if not, you'll have to discover the one leaf that's directly connected, one or more spines, and then after the spine, all the other leaves in the topology. And then when that happens, the APIC, the second and third APIC, can then form a cluster. So let's go back to Fabric membership and see if any other nodes have been added to the nodes pending registration. So you see node 103 has been added. Again, in the real world, it's going to show you an actual serial number, and you choose the node name. Here, I'm just making sure that I select items that are highly likely to be acceptable by the simulator and not cause discovery problems. The role does need to be selected. In this case, in 6.0 code, when you discover endpoints, compared to earlier code, what happens is that some devices, some switches are going to be dual use, so you can deploy them as a leaf or a spine, whereas in older older switch versions, they were not convertible. But in this case, I need to actually select spine to ensure that it is recognized and as a spine and activated correctly. So I'm going to go ahead and register both of them. Node ID is going to be 104 in this case, and I'm going to select TEP-1-104. Role, again, I'm going to select spine and register. Okay, if this happens, then it is possible that you just need to refresh the session. I'm going to do that. I'm going to go under Fabric again, Fabric membership, and let's register these over again because there must have been some problem between my web client, this web client, and the APIC. Node name, I'm going to just select the default node name and spine register. Register node ID is going to be 104 and TEP-1-104. So this is going to take a minute or two. Let's go back to system under controllers and see if that one leaf, discovering that one leaf did anything. So leaf 2 has been discovered. If you're wondering why, maybe it is possible that leaf 3 has dual connectivity. APIC 3 has dual connectivity as well. But what happens is that one of these in-band connections from an APIC is only going to be active at any time. It's more of an active standby from a discovery perspective. So it is possible that we have to wait until that last leaf is discovered for the cluster to fully form. Now, if we were to look at the status under cluster as seen by node, one thing that you will see is that the health state for these two is fully fit. which basically means that they are healthy and correctly sharding data between the APICs. So fully fit, if you didn't catch any of that, fully fit means the APICs are healthy and functional and communicating with each other properly. Fabric, under Fabric membership, we're going to go back. We see that these are active. Therefore, in the output of LLDP, one of these spines at least should see the other leaf in our topology, and therefore it should show up in nodes pending registration. I'm going to select register, node ID is 102, and node name, I'm just going to select the same node name that is here. And, oh, okay. Fat fingered something. Node name, tep 102, register. And once this goes inactive, we're going to expect to see the last controller become operational. Now, there isn't really anything else for us to do here. After this, you basically form the cluster, the switches have created the connectivity, the APICs have created the connectivity within the fabric, all nodes within the fabric have the proper tunnels established. Once they're all active from a Fabric membership status perspective, the final question is, what do I use simulator environments for? Personally, I think that simulators aren't really the best option to use for initial learning. You probably do want to use a hardware-based topology first, because there are some limitations. For example, you will see that you will be able to SSH into the APICs, but even though it allows you to SSH as well to the switches indirectly connect from the APIC to the switches, it will not show you the standard SSH prompt that you would get when you were to log into the switches. So there are some limitations. Obviously, this is not a data plane platform. It's more for you to get your feet wet in how you might configure things. But the problem is that you don't have the same ability to verify things. You don't have the ability to, let's say, log into the CLI of a switch and see if a contract has been deployed properly. You're not able to verify that, let's say you deployed a policy and is it actually working? The pings will not be there. Again, it's not really useful for data plane testing. However, what happens is once you do have the know-how and you are really good at how ACI works, using the simulator is great for testing automation. Sometimes I use it to see the new features that are maybe in a new code if the fabrics that I'm using can't be upgraded for whatever reason. Hopefully those of you who have been looking for a more affordable fallback option for your training now know of the Cisco ACI simulator and how to install it. If you found this video to be useful, please like and subscribe. We will be rolling out content around data center SDN, zero trust networking, and network automation on this channel. Thank you for viewing.